welcome everybody to our next example here in section 8.1. It's example 3, and the title of example 3 is how to apply equations in the form of ax equals b. Now for this particular template of types of algebraic equations, the difference really here is that our variable is going to appear in our denominator, which is going to require one extra step in terms of isolating it. So let's take a peek at what the example was that the book gave us. It says the formula for speed is speed equals distance traveled over the time it took to go that distance, or S equals d over t. Now when we read the story problem, it says the length of a Canadian football field, including the end zones, is 137.2 meters. So that would be the distance traveled. So if you look here, if we think about that, we're pretty sure that since the context of this is the distance they're going to travel is 137 meters. And if a horse gallops at 13 meters per second, how long would it, 13.4 meters per second, how much time would it take? Well, we have to say, is this, which one is 13.4? Is that the speed that we're traveling or the time that we're traveling? And it's actually the speed at which we're traveling. It's the rate of speed. So we can substitute that for 13.4 meters per second. So really, if you look here, meters per second is meters per second. This is why we're going to figure the time. So really, these units are insignificant because our time is going to be what we actually look for. Okay, so distance over time equals speed. That is my formula. So I substitute what I know. So speed is 13.4. My distance is 137.2 meters. And my time in which it took me to go that far is unknown. So what it says here is, if you look at the solution to it, we substituted known values, and then in the little bracket there it says, why do we multiply by t in this case? Because I changed it to f. Why do we multiply by x? Well, if we're following algebraic form, opposite operation will always negate certain things that we want to eliminate. But we say, well, hold on, we don't want to eliminate the x, but we do want to eliminate in the denominator. So if we look at this and interpret this as being dividing by x, then this part here, multiplying by x, will get rid of it. So we're going to really counteract or use opposite operation to get rid of the x in our denominator. And over here, what we end up having is 13.4 times x, or coefficient variable relationship. So we actually have 13.4 times x, 13.4x, equals all that's left over here, which is denominator here. Now what I have to do is divide both sides by the coefficient. Divide both sides by the coefficient. And I end up with the answer, t is, and they use the wavy line because really we estimated the distance in time, or when we did the division it was a decimal. 10.2 is our answer. So the time it took to go the length of a football field, traveling on a horse, galloping at 13.4 meters per second, it took us 10.2 seconds to cover the distance of the field. All right, let's try another one, see if we can figure it out. Now, unfortunately, the show you know is in the context of a over x equals b, but let's look at the show you know question at the bottom of page 298. So we're here still at 298. The show you know. It says, if a musher and her dog team traveled 23.5 kilometers per hour during a dog sled race, how long will it take to sled 50 kilometers? Okay, you go ahead and try that. See if you can figure out how to do it. I will give you the hint. Yes, we will be using the same formula from the context. Okay, I'll press pause. You go ahead and work it out. Execute, press pause. And when you're done, re-pause, and we'll go over the answer. Okay, welcome back, and here we have our formula again. Now, as you looked at your known parts, we had two parts. We had 23.5 kilometers per hour, and we had 50 kilometers, which was the race. So we have to say, well, which one is 23.5 kilometers per hour? Is that the distance, is that the time, or is that the speed? Kilometers per hour is a rate of speed. So that's actually going to be substituting here for our speed. 50 kilometers is the distance the dogs travel. So we put that there. And our time, I'll leave it this time as a very key. It's something I don't know. So we have an equation set in the style of A over X equals B. So we have a variable in the denominator of our equation. So the first thing I want to do is I'm going to get rid of the t in my denominator because it says dividing by t. I multiply by t, get rid of it. I multiply by t over here. Remember, this is a multiplication of a variable and a number, which means the number can act as a coefficient. By the cumulative property of mathematics, it doesn't matter the order in which I multiply. So 23.5t equals what's left over here, which is 50. Divide both sides by my coefficient, or use opposite operation if you want to think of it like that. Multiply by 23.5t divided by it. Cancels each other out, and what t equals. The answer to 50 divided by 23.5, which is roughly 2. We'll get the actual answer. 50 divided by 23.5 equals 2.12. The time it took, 2.12 hours to travel that distance. So that's your answer. Now, this is interesting here. 12 hundredths of an hour. 12 hundredths. That's what decimal 1, 2 of 1 hour. If you wanted to be a little bit more precise, you could actually go do this. 12 100ths of 60 minutes is what? So really what I have here is a multiplication of two fractions. So I can multiply 60 by 12, which is 720, divided by 100. Knock 2 off there, knock there. So it's actually 1 hour and 7.2 minutes. 1 hour and 7.2 minutes. Hold on. How long is 0.2 minutes? Well, 0.1 minutes, 10th of a minute, 6 seconds. So therefore, 0.2 minutes would be what? That's right. 12 seconds. So we can actually say 1 hour, 7 minutes, and 12 seconds. So listen, don't worry about it. If this is what you got for an hour, that's fine. But if you wanted to work it out in more detail, that's actually what, or sorry, 2 hours. 2 hours, 7 minutes, and 12 seconds. Hope that helped you. Keep traveling, keep working. Try example 8 on page 298. Watch the video.